In this video, we remove some black sticky stuff, we 3D print a missing bit, we probe an op-amp, and we watch a beautiful guitar solo on an oscilloscope. Here we have a Sony TC-W230 double cassette player. It has seen better days, and when we press play on either of the cassettes, it doesn't do anything. We do hear a motor running, so let's see what's inside. Right, someone has been here already. One of the motors is disconnected. No wonder it didn't work. We see a lot of black tar-like material spread all around the player. This is what is left of the belts that once were responsible for getting everything to move. We can see residue on the motor spindle and the various wheels. First thing to do is disassemble it, so we can clean this goo off. There are lots of wires and connectors to disconnect, but we do need to do it, because that will be the only way to separate the front panel from the body to have access to the cassette mechanisms. To make joining everything back together easier, I make a rough sketch of everything I remove and join all the loose bits to it with sticky tape, numbering them sequentially. I do this for every connector I disconnect as well. In that way you only have to follow the numbers in reverse order to rejoin everything. Remove the type selector buttons, the Dolby buttons, the power button, the headphone jack, the speed selector buttons, the display connector, the dubbing LEDs, the record level sliders, and then we finally have everything disconnected to remove the front panel. Let's remove the motor to have better access to the belt mechanisms. Now that we can access everything, let's clean the black goo. I tried just about everything that would identify as a black goo removal tool. Toothpicks, cotton buds, more toothpicks, more cotton buds, a soft brush which didn't do anything at all, the side of a cotton bud dipped in IPA did about good. Here is what's left of the belt on the other motor, which had even more black stuff. These little makeup brushes dipped in IPA did quite well. I wouldn't reuse them for makeup though. Well, that was a lot of work. Here is the pile of toothpicks, cotton buds and brushes I used to remove the tar-like substance. It was a lot of work, but it was needed. This stuff gets everywhere, so if you want to do this yourself, I would recommend gloves, which I should have used. Now we have to figure out how many belts were originally there and where they are supposed to go. I did find a service manual, but it still took me a while to figure out the whole belt structure. Here is the summary to save you a lot of time if you have to do this yourself. There are two wheels on the motor which both carry a belt. One of those belts joins with the large wheel with the black disc on top. The other belt joins with the medium-large wheel next to the motor. A third belt joins with the white wheel under the motor to the underside of the largest wheel with the black disc on top. This took me hours to figure out, so don't blame yourself if it takes a few minutes to know where which belt goes. There is one more belt that joins the tape counter to the mechanism. We'll have a look at that later. For now, let's install the belts. First, the belt that goes under the large wheel to the small wheel, as denoted in the somewhat cryptic drawing in the service manual. Then we rejoin the motor with the chassis. Rejoining it with the chassis is a bit fiddly, so I'll show you a close-up under the microscope so you can see how it is supposed to be done. Then we screw on the motor. Then we can insert the belt joining the black disc with the motor. It goes into the wheel that is closest to the motor. There is a little gap between the white cogwheel and the wheel of the motor, which is just wide enough to get the belt through. Then we join the other wheel on the motor with the large white wheel to the side of the motor. Now we can rejoin the metal cover with the mechanism and reattach the black plastic parts to the side of the mechanism. Now that we disconnected everything from the front panel, it's a good time to clean it a bit. I'm using cotton buds and makeup removal pads with some isopropyl alcohol. There, that's a lot better. Before rejoining the mechanism with the front cover, we install the belt for the counter. One side goes into the groove in the black spindle that turns the actual cassette, and the other side to the wheel that is attached to the counter. Unfortunately, deck B, the right deck, won't stay closed anymore. So let's see what's wrong there. The closing mechanism is an ingenious collection of plastic bits that operate together. The plastic piece on the side of the mechanism seems to be a bit loose. Let's check it under the microscope. So a little piece of plastic has broken off that prevents the part from moving in the wrong direction. Since these parts are probably near impossible to get, we're going to repair it by 3D printing a small plastic piece to join with the part that prevents it from moving the wrong way. So we design a very small piece of plastic that fits where the bit on the original part broke off. It's only 4 by 6 millimeters, but it will probably do the job. Now let's print it. That didn't take long, so let's join it with the part we are fixing. The next day the glue hardened and we rejoined it with the plastic bit on the mechanism. And there we go, a well-working cassette lid on an 80s machine with a little help from some noughties technology. Now both mechanisms are playing, but deck B has no sound. Let's see how we are going to solve that. The first thing I did was download the service manual. It was easy to find by searching online for Sony TC-W230 service manual. Here we see that the input from the heads goes straight into a little 5220 op amp, of which the datasheet shows that the amplified output should be on pin 1, called output 1. When we use an oscilloscope to probe pins 1 of both deck A and B, we find that everything up until and including the op amp are fine. Only deck A has sound and B has not. The next thing on the signal path is this multiplexer chip that decides which player gets its sound forwarded to the output. This multiplexer must get a signal to determine which deck is playing, so maybe deck B isn't communicating with the board when play is pressed. To find out how the decks communicate their play status with the board, we can measure the voltages on the connector and check which voltages change when play is pressed. When we measure one of the gray wires on the connector, we see that it switches between plus 6 volts and minus 6 volts, depending on whether play is pressed or not. This gray wire turns out to be connected to a switch in the cassette mechanism that gets switched when play is pressed. It's probably dirty, so let's clean it. I had to remove the whole mechanism again to clean it, but a cotton bud with some IPA easily did the job, and now both decks are playing. What a result! So this little video is a summary of a couple of days work and will hopefully make your life easier if you want to service your tape deck as well. Thank you so much for watching this video. Please like and subscribe or be my total hero and join the channel by pressing the join button. It's cheaper than buying me a beer every 6 months, so please join me and keep those electronics from ending up in a scrap heap. I hope you will join me in the next video. Bye then!